Hello everybody, May 26, 2019. Doc Hydro here. Listen, I need to go over something because a few of the folks that were in the Engine Academy were having a little bit of a problem trying to figure out the numbers and whatnot. And especially with a progressive. And a progressive, if you remember, is got laterals, and then it's got a farthest nozzle and so forth. And it can either be a lateral itself, or it can just be straight off the end of the hose. So here's what I want to do. I want to set up a situation that's similar to what we just went over. So right here, what we're going to do is we are going to draw our trunk line, okay? And we're going to say that that's our trunk line. The total length is going to be 700 feet. Okay? 700 feet from start to finish. However, minus 200 feet from the end, okay, is going to be a lateral. Okay? So we'll say that that's right there. So what we've got then is we've got from here to here is 500 feet. Now we'll also have some elevation gain, okay? So we'll say, even though that this picture is quite high, the situation that we were using out in the Engine Academy was only about 60 feet of head. So just pretend that this hill's a lot smaller than it looks. So 60 feet, okay? So that's what we got. And then what we've got is we've got 200 feet, okay, so 200 feet, and then we've got 500 feet for a total of 700 feet. On the end of this nozzle, or this hose, we had an 1.5 inch and then a 1 inch, okay? So we'll have 1.5 and 1, okay, for our nozzle sizes. And they were combination nozzles, adjustable barrels, so smooth, straight stream, and all that, or fog and straight stream capable is what they were. So what you're going to do here at this point now is the one thing that you can't overcome is going to be your head pressure. So what you do is you start with your head pressure, okay? And so you say, okay, so we got our head pressure of 60, and you can divide that by 2 to get 30 psi. Okay, so that's your head. So head equals 30 psi. Nozzle pressure, if you look in the IRPG for an 1.5 inch, because that's how they're ready to flow 60 gallons a minute at 100 psi. So you got 100 there. Okay? And so now what you got to do is you've got 130 psi total so far. You got 30 psi in elevation, 100 psi on the farthest nozzle, but you still aren't going to get water up there because you don't know what the friction loss is going to be for the sections. So this is how you do this. So what we're going to do is we're going to get rid of this, and we'll get rid of these for the most part. And what we will do now is say, okay, so we've got to add these, we got to determine our total flow. How we do that is on page 87 of the IRPG, we know that a 1.5 inch equals 60 at 100 psi, and a 1 inch equals 20 at 100 psi. Okay? So, that's gallons per minute. So, 1.5 inch and 1 inch. Add those two flow ratings together and you come up with 80 gallons a minute. So now, the 80 gallons a minute is something that you want to make sure that you can provide from the engine up to the first lateral. Okay, so that's what we're looking at right here. 80 gallons a minute. And so you sit here and you've got your engine right here. Okay? And so what we need to do is we need to be able to provide 80 gallons a minute to this point. And then after that, 20 gallons a minute is going to be consumed by the first nozzle. So then we subtract the 20, we got 60 left, and that's what's going to be flowing to the second nozzle. Okay? So now, the two friction loss numbers that we got are we got to figure out what the friction loss is for 80 gallons a minute for 500 feet. So, 80 GPM at 500 feet. So, how many sticks to 500 feet? You got 5. And if we sit here and look at 80 gallons a minute on our Cascade Fire Slide Rule for 1.5" size hose, single line, we can see that we got roughly 22.5, approximately 22.5. That doesn't look very good there. So 22.5, which equals, and if we'll do the math, we'll just do that right now. So 22.5 times 5 is 112.5. And then 60 gallons a minute, well, I already know that. That's pretty easy. So we've got 2 times, we'll just round it to 13, equals 26. So 112.5 plus 26 equals 138, okay, and a half. And then we've got the nozzle pressure of 100, okay, which is 238. And then we've got the elevation over here of 30 psi, or 60 feet. And so then that comes down here of 268 psi. And that's basically it. That's how you do that. But you want to add your gallons per minute ratings. You do not add all the nozzle pressures. And you'll notice in that I did not add the friction loss. I did not add the friction loss for the lateral. Okay? That's how that works. And you can even see that for those that were in the academy this year. You got my booklet. So you'll even see that on page 11 of the booklet under number 5 for progressive hose lays. It says determine friction loss either by using the Cascade Fire Nozzle Discharge / Fire Friction Loss Slide Rule or by the formula above, using the hose diameter coefficients. Make sure you obtain the friction loss between the laterals, but do not count the laterals friction loss except the last one. So, here's what this means. So let's say, let's erase all this ink and let's start over. So let's say that we've got our hose lay again, but now what we do is we got laterals here, 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 and here. Okay? So what this says is that you count the friction loss between the laterals, like in the trunk line, so that means you'll count the friction loss here, okay? And then here, and then here, and then here, and then you'll count this last one's friction loss, but you do not count the friction loss of those laterals. That's what that means. Now, lastly, what people will do is they come up here and you've got a couple of laterals. They start adding, so you got nozzle pressure, and then they'll want to add nozzle pressure and nozzle pressure. Okay? You do not add those nozzles. You only count the last nozzle. And so that's basically that. If you have any questions, like normal, you guys can give me a holler. And that's it. Thank you.